Our solar system is a well-oiled machine. Every planet, dwarf planet, moon and asteroid goes about its business in a carefully choreographed dance that has been perfected over billions of years. But what are the rules of this cosmic ballet? How does everything stay in its place? And how did our solar system come to be? In this series, we will explore the secrets of the motions of the planets and moons. We will learn how gravity plays a starring role in the drama of the cosmos. And we will uncover how our solar system came to be the way it is today. So buckle up, space cadets. It's going to be a wild ride. Have you ever gazed up at the night sky and wondered why the planets move the way they do? Do the planets really go around the sun like the Earth? What keeps the planets in their orbit? To understand these mind-boggling questions, we must first turn our attention to the most fundamental force in the universe: gravity. Every object in the universe attracts every other object with a force that depends on their masses and the distance between them. The closer the objects are to each other, the stronger the gravitational force between them. But it's not just the planets that are affected by gravity. The sun, with its massive size, exerts a gravitational pull on all the objects in the solar system. This means that the planets are not just falling around the sun, but they are also falling around each other. To make sense of this cosmic chaos, scientists use a technique called vector addition. Vectors are mathematical quantities that have both magnitude and direction. So if you know the position and velocity of an object, you can use vector addition to predict its future position in motion. By applying Newton's laws of motion and gravity, scientists can model the positions and velocities of all the objects in the solar system and accurately predict their future positions. It's like a cosmic game of billiards, but with planets instead of balls and gravity instead of collisions. With this knowledge, we can unlock the mysteries of the movements of the planets and moons in our solar system and appreciate the delicate balance that keeps them in their intricate dance. But that's not all there is to the story. There's more to the solar system than just the sun and the planets. There are also dwarf planets like Pluto and Eris, as well as millions of asteroids and comets. All of these objects are affected by the gravitational forces of the planets and the sun. To understand how the solar system works, we need to know how it all began. In the beginning, there was a giant cloud of gas and dust. Over time, this cloud began to collapse in on itself due to the force of gravity. As the cloud collapsed, it began to spin faster and faster until it formed a disk. In the center of the disk, the material was hot and dense enough to cause nuclear fusion to occur, giving birth to our sun. Around the sun, the leftover material continued to spin, eventually forming the planets, moons, asteroids, and other objects that populate our solar system today. But how do we know this? Scientists have studied meteorites from Mars and other rocky bodies in our solar system to determine their age. They have also studied the isotopic composition of these meteorites to learn more about the conditions under which they formed. These studies have revealed that all the objects in our solar system are around 4.6 billion years old, which means that the solar system is very old. With this knowledge, we can better understand the history of our solar system and our place in the universe. The journey through our solar system is a wild one. Let's take a ride from the sun to the Kuiper Belt. As we leave the sun, we enter the inner solar system, home to the rocky planets Mercury, Venus, Earth, and Mars. Then we cross the asteroid belt, a region populated by millions of asteroids. Beyond the asteroid belt, we find the gas giants, Jupiter, Saturn, Neptune, and Uranus. Each planet has its unique characteristics and many moons and rings, but the action doesn't stop there. We continue our journey into the outer solar system, where we find the ice giants, Neptune, and Uranus. Finally, we reach the Kuiper Belt, a region of icy bodies beyond the orbit of Neptune. Here we find dwarf planets like Pluto and Eris, as well as countless other objects from the early days of the solar system. As we travel through our solar system, we witness the incredible beauty and diversity of our cosmic neighborhood. Each planet and moon is a unique world with its own story to tell. So keep exploring and stay curious, space cadets. You never know what wonders you might discover next. Thanks for joining us on this incredible journey through our solar system. If you enjoyed this episode, be sure to stay tuned for more updates. Don't forget to share your thoughts and comments below. Till next time, keep looking up.